So thanks everyone for joining us this evening for the Coastal Acidification in the Classroom, Next Generation Science Standards Aligned Standards for Use in Classrooms. We have our 2025 MACAN Education Fellow who will be presenting tonight. Her name is Jennifer, and I really hope I'm pronouncing this right, Porcheddu. And Jennifer has been a teacher in the New York City public high schools for over a decade, I believe.
Over 2 decades.
Over 2 decades. And she is going to share with you she's going to share with you not only how this curriculum was developed, but she's going to go into a decent amount of depth about the curriculum itself. Jen, if you could go to the next slide for me, please. So for those of you who may not be familiar with the coastal acidification networks, there are 7 acidification networks across the country. And I also want to point out that our sister networks of SOCAN, the Southeast Coastal Acidification Network, and GCAN, the Gulf of America Coastal Acidification Network, helped promote this webinar, and we have representatives from SOCAN and GCAN with us here today. The CANs were established I'm sorry, I don't remember when the first one was established, but it was the California Current Acidification Network was the first one. And then there was legislation in 2009 that established the CANs kind of officially, that was reauthorized with the congressional budget in 2020. In 2020. It's been a long day. And that's administered by NOAA's Ocean Acidification Program. So the CANs are essentially a virtual network of scientists, federal, tribal, and state agency representatives, resource managers, non-governmental organizations, and other industry partners. MACAN specifically focuses from Long Island Sound to coastal Virginia, and this presentation today is going to be particularly based in the Mid-Atlantic because that's where we are. And essentially, all of the CANs have very similar goals, which are to guide regional observation, research, and modeling, understand local drivers of acidification, predict consequences for marine resources and local communities, and coordinate best practices for monitoring and data collection, and finally, educate stakeholders on ocean and coastal acidification impacts and solutions. So we cover a wide range of topics, issues, and provide also a wide range of resources. Next slide, please. So just to give you a little bit of the project background, this was originally a MACAN project that was centered in the Mid-Atlantic, and it was developed, we were keeping in mind essentially Mid-Atlantic coastal and ocean acidification resources that were currently in use so that we could build on those. We used lessons learned that focused lessons learned primarily from the West Coast as the CAN itself was developed, but also from educational materials that were already developed or that were already available. And we realized that there were few resources on local drivers to coastal acidification and the impacts to mid-Atlantic species and habitat. So we wanted to not only develop those types of resources that focus on species and habitat, but that incorporate species and habitat resources into curriculum and educational resources. So this project was the first iteration of it is a coastal and ocean acidification classroom module that was developed by 3 Mid-Atlantic National Estuarine Research Reserves and MACAN, and that was used initially only during Teachers on the Estuary or TOTES workshops. And so then there was a second iteration of it that was updated by Bethany Klein and Greta Olson, who were summer interns. And they were supported by the Chesapeake Bay National Estuarine Research Reserve, the Delaware National Estuarine Research Reserve, and the Jacques Cousteau National Estuarine Research Reserve in Virginia, Maryland, Delaware, and New Jersey, respectively. So we developed this classroom module, but then we wanted to turn it into a standards-aligned curriculum as a long-term goal using first Mid-Atlantic specific examples. And then we hope that this will become kind of a resource for other regions to use and apply their own local examples so that it can get into classrooms all over the country. Next slide, please. And just also to give you a little bit of background on what the MACAN Fellowship is. MACAN for the last few years has been able to provide fellowships. Jennifer was our third MACAN Fellow. And when we advertised for this fellowship, we were looking to expand the coastal acidification curriculum using real-world monitoring data, update the curriculum to align with the next generation science standards so that it could be very easily accepted into public school curriculum, and to develop 2 biological impact lessons. I believe we have more, and 1 data mystery lesson focused on Mid-Atlantic appropriate, on the Mid-Atlantic and appropriate for grades 9 through 12 for biology, environmental science, or chemistry classes. That is why we were specifically looking for a high school teacher who is interested in working on this project, because we wanted it not only to be based on real world examples of data and science, but also real world teaching and accessibility to classrooms. So I'm going to have Jennifer take it over from there, and we will have time for questions and answers at the end. And also, if there are any teachers that are in attendance this evening, stay tuned, because at the end of the presentation, we will let you know how you could potentially get some continuing education credits by attending this evening's webinar. So thank you all again for attending, and take it away, Jen.
Thank you so much for having me. As Janet introduced me, I'm Jennifer Porcheddu. I'm involved with all sorts of things, but it's been a real great time working with the MACAN folks to put this curriculum together. It was already excellent, but I was brought on to add a few extra things. And this is a quick peek of our outline for today. We'll kick things off with a recap of ocean and coastal acidification to make sure we're all on the same page. Then we'll dive into the curriculum structure. And then most importantly, we'll spend some time showing off some of the activities, specifically the Lego Build-A-Shell game, Case of the Vanishing Scallops. And we were thinking together we'll do the bivalve data analysis activity, but we'll see how timing goes and how we can get that organized. So ocean and coastal acidification is a complex environmental issue. It connects to global climate change, but it pops up with its own unique local problems in our nearshore waters. It's a big topic. It affects everything from marine creatures to the people who rely on the coast for their income. So how exactly does carbon dioxide alter the chemistry of our oceans? Well, when water combines with carbon dioxide, they create carbonic acid. The extra carbon dioxide we pump into the atmosphere ends up increasing the carbonic acid in the ocean, which in turn drops the water's pH, making it more acidic. So why the big deal? Carbonic acid is a weak acid, but it still packs a punch. Primarily, the hydrogen ion preferentially bonds with the carbonate ions. Carbonate is the key ingredient for calcium carbonate that shelled creatures like oysters, clams, pteropods use to build their protective shells and skeletons, which are made of calcium carbonate. And by stealing this essential ingredient, we make it way harder for these animals to build and keep up their shells, and it puts the whole ocean food web at risk. When we talk about coastal acidification, we're talking about what happens in the waters right near the shore and in estuaries. Here, the problems from ocean acidification often get worse because of other local issues like pollution runoff from land, areas that are experiencing hypoxia, changes in how the water moves, like upwelling. And that's why a curriculum focused on the mid-Atlantic, which is full of estuaries, has to deal with these unique coastal drivers. So as for the curriculum, besides being super important environmentally, ocean and coastal acidification is an awesome subject for teaching to the next generation science standards. It's built with NGSS in mind. It offers tons of chances for students to ask questions and investigate. You'll find activities that blend cross-cutting concepts, provide hands-on science and engineering practices, and help students really grasp the disciplinary core ideas. It really truly is an interdisciplinary topic. And you know, our goal was to let students build critical thinking skills, data analysis skills in a real world problem. As a teacher, I really wanted to make this very flexible, ready to use, easy to edit. It was made by educators with for educators in mind, which means you get complete, ready to go lesson plans, slides for your presentations, student worksheets with answer keys and easy supply lists. You can use this series of lessons straight through if you have an elective class, if you're lucky like me, or you can just pick and choose individual lessons to boost your existing chemistry or biology or environmental science unit that may incorporate this topic. There's a full table of contents, and the summaries will help you quickly find the lessons that fit best. Let's see. The flexibility of this module is something I was very focused on, whether you need a quick lab for one day or a full unit for, well, I would say about a 3-week section if you really wanted to spend the full time. You can tweak this curriculum to fit whatever your teaching schedule demands. So now we're going to kind of walk through the 8 modules. You'll see that, we kind of follow sequentially from the very beginning, early causes, all the way through to some of the effects of ocean and coastal acidification. But how that starts is in module 1 with the overview. I want to spend a minute in the overview folder. There is a section with the brand new MACAN videos. They're YouTube videos that a lot of time was spent putting these together. They're really accessible. You can see the thumbnail down here. Additionally, they have Spanish subtitle versions as well. And in the folder, we have transcripts of the videos to make it further accessible for our students with different learning needs, as well as questions that teachers can use. This is great if you're doing a flipped classroom scenario. A flipped classroom scenario, you want the kids to start researching about it at home, or your kids are audio visual learners and that's what you'd like to have them do in the class. It's also great as a teacher background resource, with all the videos, if you yourself are trying to get comfortable with this curriculum or this topic. But in addition to the videos, which are also up on Edpuzzle, by the way, if anybody uses that. In addition to the videos, there's also some reading material for teachers, as well as the table of contents, which gives a tiny 2-sentence summary, basically what I'm about to tell you now, of each module, as well as the amount of time it takes to complete. Let's see here. Module 2 is, when we start getting into the material itself. Carbon dioxide, the carbon cycle, is key to understanding the main cause of ocean acidification. There's a slide presentation on the carbon cycle, and then the fun interactive carbon cycle game. Maybe you've done this before. A fun tweak that was added was putting differently colored beads at each station, which allows students to make a very cute visual. It's described in detail in the lesson plans. My students really liked it. It also gets the kids moving around the classroom as they identify where carbon comes from and where it goes. And This section usually takes about two class sessions, 45-minute class sessions. And so it's great even if you're just looking to start teaching about the climate. Module 3 starts connecting the carbon cycle to the ocean. Here we use a demonstration to show how carbon dioxide, even from their breath, changes the water's pH. There's an ocean acidification experiment in which students place chips of seashells in different pH water just by adding lemon juice to take a look at how it impacts the shells after they're left to soak there for a couple of days. And that kind of points to the fact that all the supplies that are needed are either easily accessible or very inexpensive on Amazon, and we've included links for all of this. Yes, okay, great. The next section is about the chemistry of ocean acidification, and this is where it gets really fun and hands-on. We've had previous feedback from chemistry teachers that indicated that they were happy to have fun hands-on lessons for this topic. The first is the combustion lab, which uses a candle and bromothymol blue to prove that burning stuff changes pH, which is great for reinforcing the whole carbon cycle, carbonic acid situation. And it's great for teachers that are okay with an open flame. And then the second, the Lego Build-A-Shell lab, is a blast. We'll take a look at that a little more closely. And it uses 3 colors of Legos to show why more acid in the ocean makes it harder for seashells to form the necessary calcium carbonate. Each one takes maybe 45 minutes. You might include answering the questions as a little longer, but they're a lot of fun and the kids like them. Moving on to the second half, the last 4 modules, we kind of shift from the global picture to how acidification impacts things locally. Module 5 is important for highlighting the unique struggles in estuaries. The students look at infographics and data to see how acidification affects coastal waters differently in the open ocean. It's great for helping students get better at reading and understanding different types of data, and it only takes a 45-minute class period. Biological impacts dives into what happens to living things as the ocean pH drops. They use different styles of data tables to figure out how acidification impacts various mid-Atlantic organisms. And they build concept maps showing the connections between organisms and a changing ocean pH. This module is also designed for 1 or 2 45-minute class periods, depending on whether you want to do the extensions or not. Which brings me to the point, there is differentiation included in each of the lesson plans. All right. Module 7 is the one that we're going to kind of play around with a little bit together. It's perfect for group work. It gets students to collaborate. They start by working alone to interpret a particular data table. Then in groups, they combine their findings to draw conclusions about how more dissolved carbon dioxide impacts the health of bivalves. And again, this can take 1 or 2 class periods, depending on what you have the kids do together and separately. And the last is the case of the vanishing scallops. That's the final section. Primarily, I'd like to point out that it's interdisciplinary. It uses podcasts and videos and newspaper articles to explore how students followed a decline in bay scallop populations. And then there's a section in which they get into their own experimental design. We'll explore this one in more detail in a few minutes. But again, there's a lot of access points for all the types of learners. All right, so that is the rundown. So we thought we'd take a look at these lessons, a couple of the lessons in action. We're gonna check out the Lego Build-A-Shell lab, the Vanishing Scallops case study, and then we might try to get some group participation with the bivalve data analysis. So first up is the Lego Build-A-Shell lab. I can't take credit for this one. This one was great. It was already there. I just put together some, supportive activities that go with it. This is one of the more fun ways to model the chemistry of acidification. And as we said, the whole point is to show how more acid, represented by Legos, makes it harder for shelled animals to create calcium carbonate. In this lab, every color of Lego stands for a different molecule. You only need 3 colors, easy to find on Amazon. We included the links, or you could just raid your kids' box of toys. Students learn which one is necessary for carbonate, is the necessary carbonate for shell building. That's the yellow. Which one is the necessary carbonate for shell building, which one is calcium, and which one is the acid, the H+, the red one. And then we set it up in 3 rounds. Round 1 represents the pre-industrial era, and as you can see, it has fewer of the red Legos, which represents a lower amount of acid. Round 2 models the current industrial era with a bit more acid, and round 3 simulates a future worst case scenario with a lot of extra acid. And notice how adding more red or acid molecules changes the environment. And it's a game. It's fast. You know how the kids get competitive. In my class, we did a practice round first just to make sure everybody understood the rules. And then we let them kind of time each other and go at it. But it's supposed to be fast and exciting. Each student gets 60 seconds per round to reach in with one hand only into the bag and pull out one single Lego at a time. The rule is that you have to pair a piece right away if it exists. And the trick is, say perhaps the child has a free blue piece out and a free red piece out, they would be free because they can't bond together, as you can see by the chart. And now they next pull out a yellow piece. The yellow can only bond with, in that case, it preferentially bonds with the red, the acid. And that's kind of the whole point, is that the carbonate preferentially bonds with the hydrogen ion as opposed to the calcium, which is the more useful of the two. And what ends up occurring is the game mimics the competition for the carbonate ions in the ocean and represents how more acid makes fewer calcium carbonate pairs, thus impacting the organisms that rely on them. So this one's a ton of fun. And of course, more fun in person when we get to have you guys try it out. The next one that we are going to talk about is Module 8. This is the case of the vanishing scallops. It's a true story. It uses podcasts, articles, and videos to get students hooked on a complex environmental problem and explore how science really works, that it's never just a straight line. And we kick off at the start of the scientific method, noticing a problem. They explore different media, like news clips, to understand what people are seeing about the bay scallop populations, the fact that they're disappearing. And we brainstorm all the different impacts of this die-off, not just the environmental consequences, but the economic and human impacts, like jobs, tourism, etc. And this is probably the longest module if you were going to use all the pieces of it. I designed it with my own types of students in mind. The purpose was to kind of lead them through designing their own experiment to explore this issue. And so it really goes step by step if it's something your students need. Again, it's highly editable if needed. But even the very basic, the hardest part for students moving from basic questions, the very beginning, to deep investigative questions. We encourage a little bit of struggle, generating at least one of each of the traditional question words, a question about the bay scallop die-off to make them think a little bit more deeply about what they might want to investigate. And this process pushes them eventually towards forming hypotheses that they could actually test. Once they have their questions, the curriculum shows them some actual research that's been done. They look at journal articles, this really great podcast, and news segments to see what scientists have already worked on to tackle this problem. And this stresses that science is always a work in progress, very important for the NGSS science and engineering practices. And then from there, the students generate hypotheses based on the questions they generated and work through turning it into a detailed experimental design. The module includes lots of supports for the teachers and the students in taking this route. For my students, this took a while. I feel like it was worthwhile, but again, if you were pressed for time, if you didn't have an elective class, you might want to condense this part, and all the materials are set up for you to be able to do that easily. All right, so the last thing we're going to talk about is the bivalve data analysis. It's great for teamwork. It focuses on two important mid-Atlantic species that a lot of the kids who if they live near the shore, might already be familiar with. Common seashells you find on the shoreline, the hard-shell clam and the bay scallop. And what happens is I'm sorry, let's make sure. It uses real research to drive home the point that carbon dioxide concentrations and decreased pH have an impact. And what it does is it uses a jigsaw setup for collaboration. There's a total of 8 tables that were used in the research study that I just scrolled past. And they each receive 1 or 2, depending on how you have your group structured. And the handouts that are associated with this each have one of the data tables with the questions. About just their data table. And then as a group, they combine their personal findings to answer a final set of big picture questions. As you know, NGSS requires students to spend a lot of time interpreting really complex charts, data, and this was designed to be scaffolded for this purpose. I'm sure a lot of you got to try out the new Earth and Space Science and biology if you're from New York, biology regions this year, and there was a lot of interesting tables for the students to interpret. So this is an opportunity for them to hone that skill while learning about ocean acidification. So originally we were thinking about splitting into breakout rooms, but I think that's not the plan now. What are we thinking, my fellow hosts and presenters? Should we share the worksheets, or what should we do? I'm open to anything.
The worksheets in the chat, and I think what people are going to be able to do in a little bit of their own time, and then also you're able to raise your hand and either ask a question out loud or ask a question in the Q&A. Go through these worksheets, and we were wondering if you, Jen, could perhaps talk through a little bit of what this lesson plan is like for students as they're going through it, and then we can start the Q&A a little bit early as people are also looking at this on their own time.
Excellent. So what I'm going to do is I'm going to stop the share, and I'm going to hello everyone. I'm going to stop the share, and I am going to open up that and then share that. Just give me 2 seconds there. All right. So there we go. I'm going to share again. I'm going to do this. All right. Just so we can all look at the same thing. I'm sorry that you can see my open tabs. I'll try to make that a little less visible. Let's see here. So you'll see, if you were to scroll through, that there are 8 data tables altogether. And we'll just stop at one in particular because they kind of are set up similarly. First, the first questions that the students have to approach are what's shown on the x-axis, what's shown on the y-axis. Why are there two data tables on this page? How do they differ? So it's sort of like the soft launch into looking at the data tables. I teach AP Environmental Science this year, as well as a marine science elective. And you have different levels of students, some, as many of you may already know. So the soft launch is really important for my less confident students. And just simply writing down, okay, I see that it says days since incubation. I see that it says % surviving. I see that there must be two different species. By the way, I leave this slide up when I was teaching this. I left the slide up that shows Mercenaria, Mercenari, and Argopecten. The pictures, just so they could keep picturing it. And then they take a little bit of time with the analysis. Okay, after 36 days, it forces them to note where it has numbers and so forth. So it's short, small questions, easy entry points for the kids. Also something that, they can collaborate with someone sitting next to them if they're really intimidated, easy for you to go around and check in with them. And then we tried to summarize the data in a single sentence, and that was, entertaining. It needed a little honing for some kids, and we were ultimately successful. And so in my class, we usually hang in groups of 4, and so they each had 2. Which is, and again, this is editable, and that's why question 7 is about. How do the outcomes on this data table compare to the data tables on your other sheet? So they would do first this, then they'd look at their second one and explore. Now, just to, free giveaway here, the first 4 data tables talk about the survival rates of the scallops and the clams at different carbon dioxide concentrations, which we all know is the driver of ocean acidification. And so this shows the % surviving with the clams and the scallops in data table 1. Data table 2 shows the survival rates under the current carbon dioxide concentration in our oceans. 3 shows in a projected future carbon dioxide concentration. And as you can see, but it would take the kids a minute, but as you can see, obviously the survival percentage is decreasing. And then the last one shows, a distant future worst case scenario carbon dioxide concentration. And you can see how few make it. I do end up, because it's my marine science class, I do spend a minute explaining what veligers and pediveligers and metamorphosed would look like, but again, not super necessary. Now, those are just the first 4. The next few, this shows, the next few, data table 5 shows the diameter of both the clam and the scallop under different concentrations of carbon dioxide. As you can see, their sizes decrease, with increasing concentration of carbon dioxide in the water. Data table 6 describes the shell thickness, and there's some images of that included in the slides. And again, same thing, the students are kind of answering similar get to know the graph table questions, and some more specific questions to each as they get used to it. Data table 6 talks about the lipid index, how much fats they're storing in each scenario. And data table 8 is visual, so it's a little bit different. And again, getting comfortable because it's not exactly the same style. The questions are a little bit different. But again, it's intended as a soft launch where they don't have to immediately interpret these results. They just have to look for a specific thing on the data table. And then the next step, so after the student, this doesn't take as long as it might seem, probably not as long as it took me to explain it, but each student in my class did 2 tables. So they did 1 and 2, 3, 4, 5, 6, 7, 8. And once they were done with that, they called me over, and then I gave them the group work. And basically they were supposed to answer questions that describe the overall pattern that they see. And then they were supposed to extend it to think about impacts of this, which is basically what this entire curriculum is trying to show. But this is another fun way for them to kind of get into it with their own, on their own, with their own data. So let's see, let's do that. So that is the gist of what we kind of did here. Those are 3 of the many lessons that you'll find in the new ocean acidification curriculum. Let's see. All right. Let me take a look at the chat if there's any questions I could possibly answer.
And feel free to either raise your hand and we can take you off mute to ask your question, or put your answer in the chat using the Q&A feature.
And while everyone is thinking about their questions, you can sign up for MACAN emails to receive updates about this curriculum and other resources that we offer. And if you're interested in possibly earning 1 hour of continuing education credit, please put your name and email address in the Q&A, and we will record that, and we can send a letter that states your attendance and essentially verify your participation in this webinar. But we do not guarantee that your governing body will accept the education credit. So bear with us, and we'll try to work with you as much as we can on that. So I do, Emma, if you can unmute people. I see Rick Wanenkoff has his hand raised. And Rick, I think you're off mute now. You can go ahead.
Can you hear me now?
Yes, we can.
Well, hi, Janet. It's good to see you and hear you after a long year. Just sort of background, Janet and I worked together years and years ago when she was a graduate student in Georgia. Jen, thank you for the really nice and informative presentation. I'm not an educator, but I probably in my retirement age will get more involved in education. So it's really interesting to see how you're relaying sort of critical environmental issues as a classroom curriculum, and also as that it has sort of a science-based approach. I had sort of a couple of questions. So what age range is this curriculum geared towards? And it looks like the modules, and they all look really interesting, but there seemed to be sort of a gradation in sort of its complexity. And so are there certain modules which are for different age ranges, or is it? And then also sort of follow-up question, how is this overall received by the students?
So great questions. Generally, I had high school students in mind, grades 9 through 12. But we did incorporate differentiation, allowing us to extend it for, gifted learners, and as well as more supports for those who need it. So I would say it could probably be used even at the middle school level, depending on their ability. And you're right, it was supposed to be, each module was supposed to be scaffolded upon the previous. And you'll see, in cases where it's referring to something we would have done previously, if a teacher had the time or educator had the time to go through the entire set of modules, it'll refer to something previously, but it also will have the pertinent slide in case the teacher it's a chemistry class, the kids are up to date on everything, they just want to do the Legos or something along those lines. So you're right, it is scaffolded. They are kind of building on each other. So you're right, it gets more complex, but I did, just knowing my own students and the kids that have the different abilities just based on where they are, I did try to scaffold it and have entry points for all sorts of learners. But yes, overall, I'd say high school, maybe middle school, but probably more high school.
Do you have any indication of how many teachers have taken this course and used it in their classes?
So it hasn't gone live yet, but myself and my awesome co-teacher, Amy Mullins, are both we share the 5 classes of marine science at my school. So we've been piloting it, this curriculum, since the end of September through October. And so right there, so there's two sets of classes right there. So we have that would be about, in New York, that works out to about 150 kids, and generally it is well received. They there were small modifications I made, as we went through it. I'm like, oh, we need a little more instruction here, add a slide there, but that's our pilot group. But actually, Janet could speak more too, because the initial part of the curriculum has been piloted all over the place for a while now, right? I even went to a professional development on it.
Yeah, what Jennifer's referring to is New York DEC, Department of Environmental Control, I think, or Environmental Conservation.
Yes.
Has used it in some of their continuing education courses and professional development courses. The Chesapeake Bay NERR has used it in several of their TOTES. Emily Hall and I and Angelos Hannity presented components of it at the ACE Basin Teachers on the Estuary workshop down in South Carolina. So it's been, I would say, piloted here and there, kind of piecemeal together, but we will be developing an outreach plan and engagement plan within MACAN to, and probably in collaboration with OAP to kind of follow up with folks. And hopefully there's some teachers here tonight that would, as soon as it goes live, which we expect in the next couple of weeks, pretty much around the same time that we have the webinar recorded and put on our website, and we'll email everybody about that and letting them know that it's there. And then working with Liz Perotti at OAP to kind of promote it, and obviously with our other CANs. So Jennifer is basically wrapping up her 1-year fellowship, and this webinar is part of her project deliverables. So from here, we'll kind of take some next steps within MACAN to have it kind of prepared and more broadly available.
It is great because it is a wonderful resource, and it's often that these resources don't sort of get the the airplay. Just people don't know about it. I'm sort of familiar with some of I'm quite familiar with STEM teacher in New York City, and this is something I think they would be really interested in sort of seeing this this module sort of available for for teachers within New York City, for instance.
Oh, and I will also point out that Jennifer presented this at the National Marine Estuary Association, right? NMEA. Did I get
the Educators Association?
Yeah.
Yeah.
The National Marine Educators Association this past summer.
Oh, this is fantastic. And so I said, get the word out there, because I think this is going to benefit a lot of educators and a lot of students. And this, I think, the connection of basic chemistry with environmental issues is, well, that's what got me in the field. So it's I didn't know about it till I was an undergraduate. So.
Thanks so much, Rick. And, we also rely on folks like you to help spread the word. So, from the trenches, bottom up approach. Do we have any more questions?
And I'd like to say, just if anybody's looking for an easy, an access point, just to get their feet wet. I really think those MACAN videos, and then if you want to use the questions with your class, that's such a great resource. They're like cute videos, little humor in there. It's great. It's really great, really educational. My students like them.
It's a great project to work on. So if we don't have any more questions, thanks everyone for joining us tonight. We will be sending out a follow-up email once the webinar has been uploaded to our website, and we'll provide some additional resources, including the slides from this evening's presentation in the follow-up email. And we look forward to any additional feedback that you may want to provide to MACAN on the curriculum. It is finalized, but we always keep track of everything for future updates because, as you know, as the science changes, the outreach has to follow. So thanks again to everyone who joined, and thanks again to our CAN partners who helped promote this webinar from SOCAN and GCAN. Look for future webinar series coming up in the spring. Good night.
Thank you, everyone.
Thanks, everyone.